Imagination is a gift. It enables you to dream, to fly, to reach new places, anticipate what will happen. Those who spend their time imagining are the ones who change things. They create, they inspire, they challenge. They move ahead and lead the way. Imagination moves the world. At TECHNAL, we move with it. It's a way of doing things. That's why where others see only doors and windows, we see new possibilities. We see creativity and design at the service of people. We see what is to come, a way of thinking that has brought us here. We are a company that has grown, always looking to the future. Today, we are innovators. Tomorrow, we'll be everything our imaginations can conceive. TECHNAL. Imagine what's next.
Bienvenidos. Benvindo. Welcome. Bienvenue. Ahlan wa sahlan. It's a great day today. A real great day today for TECHNAL. Not only because we are in this beautiful city of Barcelona and that the weather is just wonderful, but also because we are connected live with Dubai, with Singapore, with France, with Portugal. It's a great day today as well because we launch internationally the result of 3 heavy years of research and development. And we launch it internationally. Why? Because in fact this product already has an international story. It all started with a request coming from Asia. Very interesting request, but very challenging. We get this request, and we started to ask to many countries around the world. And at the end of the day, it turned out to be that this request was completely global. Completely global. So the team started to work on the project. But they quickly realized that, in fact, they will have to start from zero, a blank page. They will have to challenge all existing technologies. They will have to question all the suppliers. They will have to create new ideas. They will have to imagine new concepts. So obviously, when you start like this, you face hundreds of challenges, hundreds of problems, nightmare. And often, the teams have been discouraged. But at TECHNAL, with the passion that we have for what we do, we never give up. So they solved each problem one by one. They solved everything to reach the level of quality, the level of performances, the level of reliability and aesthetics that you expect from TECHNAL. So today, here we are for this launch. And in order to introduce you the best way possible this new product, we asked to one of our best specialists of the building envelope, Dr. Werner Jäger, to make you the presentation about this product. So please welcome Werner Jäger.
Hola.
Just before leaving you the stage, Werner, I would like to add 3 more things. First one is I would like to thank you all for being here and in all the places around the world to participate to this keynote. The second point, very important, I would like to thank all the teams that worked on this project and also that worked on this international launch. And the third point, you see an email address on the screen, contact@technal.com. Please send all your questions. This way it will ease the process at the end of the session. Thank you very much, Werner. The stage is yours.
Merci beaucoup. Hello, good afternoon to everybody. Hola. It's a pleasure, it's a real honor to be here. Fondation Miron is famous around the globe. It's a pleasure to be here in Barcelona for something really special. To launch something we really believe in TECHNAL is one of the most innovative and new things for the envelope that has been developed in the last years. But before we start, I would also like to thank all the audiences now in Singapore. Good evening to Singapore, good afternoon to Dubai, my colleagues and the audience in Toulouse at TECHNAL, but also, of course also Lisboa in Portugal, who are also at the same time joining us for that revolutionary next step of building envelope. Alexander has made it proper and clear. It was a long journey. We traveled 3 years down the road. We had a lot of obstacles to solve, a lot of issues to make it happen. But what is more important when you have all these obstacles, you want to reach something more. You don't only want to make a product for today, you want to reach for a product which is lasting for the next generation, probably as well. So join me a little bit in the next 20-25 minutes about what has been the real key issues we had to address during the design phase and where we came up with our design brief with these kind of solutions as such. So join us together, and at the end we will also make this kind of new product, this TIGAL by TECHNAL, all the details to you so that you really imagine what's next together with TECHNAL. What is driving us is coming also when it comes to the global development. The United Nations forecast in 2050, which is not so long down the road, just roughly 30 years, that 7 out of 10 people will live in cities. And the United Nations are just covering cities with above 10 million inhabitants. So even more people will live in city centers. And all the architects and planners of urban landscape, they know exactly what they are doing already today. They recompress the area, the plot they have available in the city centers. By having a more compressed way of building, of course, the buildings tend to become taller, to become more exposed to the nature, to face more wind loads, for instance, more rain, and the future development must cover this kind of new challenges coming out of that development. The next question, of course, besides we live in cities, we will live even more in cities, we get taller, is where does that happen? It might not happen in Europe as such, because the biggest development of new population of these 10 billion people until 2015 will be in the areas of India, of China, Asia, and Africa. In 7 years from now, it is forecasted that India will have more population than China. And also the development in the countries like Indonesia, Uganda, Congo, Tanzania, Ethiopia, US, of course, they will have half of the world growth of the population in the coming 31 years in front of us. So it will be a pretty dense development in that countries. And in that countries, of course, it is much more demanding to make this kind of solutions for all and everyone available and, of course, usable and for the future. The older I get, the more I like the studies about people getting older. Demographic, I mean, these things is something I like. Watch out, when you design something for the next future, in 2050, 1 person out of 5 will be elder than 60 years. So it's a question of security, it's a question of easy access, of comfort, of low operating forces we have to tackle with a new design brief of TIGAL by TECHNAL. In 2050, 500 million, 500 million people will age above 80. So we have to consider and we have to take care with the building plots of the future that we really make it and to really make this happen fast. Especially in our societies here in Europe, where the growing of the elderly people is faster than in other regions. And the elderly people group is growing much faster than the young population. Okay, so this must be covered by all the new product developments we are doing. When we have much more people, 10 billion, today we have roughly 7 billion on planet Earth, you all have the discussion about, does it really happen? Climate change. The question is not, does it happen? You feel it, and you see it in every angle, and I've brought with you also on the right-hand side a pretty nice plot from 1850 when the Industrial Revolution started until 2016, when you see how the climate, the temperature in average is increasing year by year over the last more than 100 years. This kind is caused by CO2 emissions. Today we discuss about a CO2 level in city centers which is called 400 parts per million. This 400 will double within the next 30 years. We are facing in 2050 double as much CO2 in our atmosphere, and CO2 is the greenhouse gas, which means it's heating up the planet Earth. Lucky us, more than 90% of this heat is swallowed by the oceans around the globe. But here the next risks come into the scene. An ocean which becomes more hot than 27 degrees Celsius develops much more hurricanes, much more typhoons, much more rain, much more problems when it comes to people along the coastlines. Reflect what I've said, where the population growth might happen. It is mostly Indonesia, it is mostly US, it is Africa. Then you have the water temperature increasing, and on the left-hand side picture, every area on the ocean which is yellow will become during summertime hotter than 27 degrees Celsius. So in all these regions, you have an increased risk of typhoons, hurricanes, and whatever could happen. The next question, of course, is you have the growth of population, taller buildings, you have the climate change. What happens? And you see it immediately when you just look on all the hurricanes occurring these days already in the past years. Around the coastlines, we will have the biggest issues on high wind loads and high rain requests. But it does not happen in Europe. I mean, in Barcelona, in Germany, we are safe. No problem on hurricanes. Why should we care for anything like that? I brought with you a picture from the European Observatory of Tornadoes. And these are all the tornadoes of the past 8 years in Europe. We have tornadoes from the classification F2, F1 until F4. F1 is 180 kilometers per hour wind speed. F4 is more than 400 kilometers per hour wind speed on the curtain wall. And you see on that picture, which is pretty impressive, I feel myself, we had in 2010 one incident between France and Belgium where an F4 tornado occurred. An F4 tornado makes a pressure as if 11 people would like to stand on a plot 1 by 1 meter. 11 people. Roughly 800 kilograms per square meter wind pressure on the curtain wall. So tornadoes also happen here. We also go high-rise, so we also have to take care with our constructions that the wind loads can be swallowed by having static, stable constructions in parallel. So being responsive to wind loads as well. These are the macroclimate issues. Climate change due to CO2 emissions. On the other side, every city is special. Barcelona is different than Paris, Paris is different than maybe Munich, and so on and so forth. I brought with me a picture of the city of Paris. And you see immediately that in the area where you have greenery, where you have rivers, the temperature in the city is much lower than in the areas where you have concrete and glass towers. In cities of today, between the glass tower areas, city centers, and the rivers or the woods, temperature is 6 degrees less in the area where you have green construction. By having this natural evaporation possible, this really leads to something special. So also here, the urban planners are not only compressing the building plot, but they have also started to green the roads, to green along the rivers, but also to green the curtain walls. Balconies, terraces will be the outcome of that kind of future development. What I like on that chart most, you see 2 lines. You see a black line and a violet line. The black line at the bottom is what could be possible in Paris by not switching on the air conditioning devices. Without switching on air conditioning devices, Paris during summer period could be 1.5 to 2 degrees less hot than today. So with our solutions, we have to take care, A, to use the space, the balconies with the greening, but also to enhance natural ventilation. Because when we can use natural ventilation in cities, we don't have to switch on air conditioning devices, which are heating up the cities in addition. So let's try to find out what can TIGAL by TECHNAL really deliver in that way of natural ventilation by it. And I'm happy also for the colleagues in Singapore that also Singapore has made this kind of simulation. What could be done in Singapore to reduce temperatures during the summer period, during the winter period? And they have made a study, if I really green all the streets, if I green in addition my buildings, the temperature in Singapore could come down 2 degrees Celsius, cooling down the city climate, being much more living into the city centers for the people living there, but also by this reducing demand for cooling, because it's 2 degrees less hot outside than without this kind of measures. So it's feasible, it's possible, but the microclimate, the greening is just one part. You have to get rid of residues, you have to get rid of fine dust particles coming from the traffics, from the truck traffic, from the heating devices. So ventilation of the city centers, it's a real issue. The ventilation of the city centers is a must, because by having a free flow of air, not obstructed by the coming high-rise buildings, but allowing even more ventilation of the city centers, gives much more advantages to get rid of residues, cool down the city during the evening time, and also enabling by this natural ventilation even for high-rise buildings. But this kind of free wind flows also means pressure fields at the curtain wall areas, which means a stiffer construction is needed to answer during storms and hurricanes these kind of requests. City of Vienna is a pretty good example how they really did it. The city of Vienna has since 5 years a project ongoing where they really make in the main direction of the wind flows new plants, new trees, and new greenery at the houses to cool down the city, to clean the air of the city from fine dust particles, but also to enable free flow of wind. Vienna is an old city. The plot is coming from the medieval time. But when you look on the plot of Vienna, the streets follow only one direction. The main roads go straight into the parallel direction than the wind forces, than the wind loads go. And the same building plot was done for Paris and for the other medieval towns. The old guys, the old architects, they knew pretty good what to do to get rid of the heat of the city and also of residues. So this is something which is coming and ongoing, and of course the buildings, they can even enable higher ventilation, higher cooling down by the right shape, by not obstructing the ventilation devices, as an example shows in Dubai on the right-hand side by Koltai facades, which could be exactly in the same purpose used to reduce residues and to have a higher increase of wind speeds in there. When we have the microclimate, we have the wind speeds. We have on the other side, of course, the devices which are heating up. And sun radiation could be for good and for bad in city centers. It also depends on the surface you have chosen. When we have concave surfaces, the sun radiation is straightly reflected into the city centers, heating up that areas by 10, 20, in some areas, like London, we have seen a project more than 50 degrees. So you have to take care about the reflectivity, the materiality of the surface, but in addition of the shape of your solution. On the other side, the convex solutions, they radiate, diffuse in all directions the sun radiation, reducing by this the overheating of city centers, and in addition, if the choice of the material is also enabling a less hotter absorption, then it will definitely reduce all the next overheating microclimate issues. What is correct for the daylight is also correct for sound. Because when we have a sound issue in the city centers, it is mainly enhanced and increasing when we have high-rise buildings. In the street canyons of today, we have hard surfaces, glass surfaces, and the sound in between is reflected multiple. And by this, the increase of the sound in city centers is more than 3 dB. What is 3 dB? The difference is 1 car is passing your building or 2 cars is passing your building. So this is something we have also to reflect. We have an increase of sound. We have to take care with TIGAL by TECHNAL also when it's closed to protect the people inside against the sound from outside. This is something which is definitely important. And then for the architects and the urban planners, something more could come into the scene. And this you see on the lower right bottom area. If you make the surface of a building in a way absorbing the sound, diffuse reflecting the sound, you can lower the sound in city centers by 8 to 10 dB, which means the impression for you as a person is as the sound is just by half compared to beforehand. And how do you achieve this? Of course, by convex solutions, could be like that, but making projections with balconies, with terraces has the same effect. So this kind of shapes of the building influence not only the overheating in the microclimate, but also the sound experience in city centers. And this is a really, really good chance and challenge for the architects to design something like that in the future. What will be the future buildings look like? Will be office buildings? Will be just residential buildings? Will be a mixed use? We think it will be a mixed use, because what we plan today as a residential could come an office tomorrow, and the day after a grocery store might enter. So whatever we do with our construction, we must be flexible, adaptable to the society and also to the development of the renting plot. And this is something we really want to see. And what you see on that chart on the left-hand side is all the tall buildings realized above 200 meters during the last years. So we grow higher, and we have more than 100 high-rise buildings above 200 meters already ready to use, which is pretty important to know. And in addition, with the plots on the lower right-hand side, you see a lot of these buildings has been along the coastlines of China, India, Indonesia, US West Coast, US East Coast, where we have the hurricanes and the typhoon classes to come. Important as well is it possible to make it? Did we already do it like that? And this is the next plot I would just try to focus on you. At the moment, 1 square meter of building ground in Hong Kong costs you 90,000 euros. 1 square meter. In Paris, it's a little bit less costly. It's 40,000 euros. I mean, 1 square meter of ground you want to build your house. So it's clear it will not be a one flat residential building in Paris any longer built. We go high rise. And the picture on the left-hand side, you see the second project where we in TECHNAL already used this technology for the high-rise towers. 2 towers, they're called Wardian in London City, where this new solution was already tested under project conditions. And for us, the challenge was, when it comes to a project, now it has to come to a serious solution, how to transport, how to transfer this kind of experiences as well. So we already built it. In addition, interesting for that chart as well is, in London, the flat in average costs you 6,000 to 7,000 euros a month. And normally you should rent that flat for 48 years before you can call it yours. Okay, so it's a long-term investment these days in London if you want to have this kind of flats installed. So price is pretty important. To summarize, buildings get taller, but with the taller buildings, we get more opportunities as architects and as planners because the surface of the envelope increases. We can harvest energy. We can clean the air. We can absorb the sound. We can bring daylight into the buildings. We can allow natural ventilation coming into the buildings, reducing air conditioning needs. All this is feasible, and with the new solutions, we have to answer this kind of demands and requests. And on the picture on the left-hand side, you see the first project we did, also in London, with this kind of solution already. It's also a more than 200 meters tall building, Newfoundland Tower, where also the principle of this, we call it window slider, was used for high-rise residential purposes. So it's feasible, it's performing, and it can be done already today. The next question we are raising also when it comes to the design brief, when it comes to the buildings, how will they really be in the future? And there's a pretty nice project in Copenhagen planned from the architects. The idea of the architects is we want to be so flexible that I don't care whether it is a residential, an office, or a grocery store area. Everything should be possible at the same time by using the same design, the same outer curtain wall. Why do I say that? When you have the opening and closing of a device, you must test. In residential, you test normally 10,000 cycles, opening and closing. For commercial, you test 20,000 opening and closing cycles. We in TECHNAL, we did 25,000 opening and closing cycles with the best performing solution. So we did even more just to enable wherever you build it, it could be residential, it could be commercial, it could be a grocery store. Regardless the use, you can use it like that. In addition, this concept for the architects in Copenhagen is pretty interesting because they want to use 40% recycled concrete. They don't want to pour fresh concrete, they want to use old concrete, redo it again, and put it into the construction as well. So think about recyclability. Reuse of material is something very, very important to us. In TIGAL, for instance, 70% of all the materials are recyclable. And due to the cradle-to-cradle certification, we removed all PVC content in our structure. So also we took this plot from the architects. What they in addition do, of course, produce energy on site. They become autonomous with the energy demand. They take care of the gray water consumption. They also, in addition, want to have terraces, but also rooftops greened to reduce temperatures in city centers, but also allowing more comfort for the people inside. So the concept is not a single one in Copenhagen. You see a lot of projects around the globe exactly with the same plot, with the same principle of idea, taking care of the nature, taking care of the use of what you already can harvest on site as well. In this context, I also would like to remind all of us, I guess you know it by heart, I'm pretty sure, in Europe, in 2020, so next year, there is a forecast, a request from the European Union that 50% of all our waste has to be taken back and recycled, taken back and making something new out of it. In the moment, we have an average of around 39% overall Europe, where we have some areas like Germany and Austria more than 60%, and others close to 60%. And even so important for all of us in the most of our countries is, what about the jobs? And in 7 years, in this area, to treat waste in a proper way, the jobs have increased more than 40%. So it will become also a kind of job machine in the future to think in the recycling, to think in the use of urban mining. Urban mining, a pretty important thing. Today, already 200,000 tons of aluminium are installed in buildings worldwide. 200,000 tons of aluminium. 40 years ago, 30 years ago, these tons are now coming back. So it would be the best thing to reuse old windows, recycle it, and bring new windows into the market. We'll have a solution to that also for TIGAL. I will show you a little bit later. To summarize what we need for the TIGAL launch, but also for the design brief, in short, it has to be resistant to heavy rain. It has to be resistant to heavy storm and wind loads. It has to answer the question, how do we keep the heat outside? How do we keep the cold outside to save energy at the inside? Also, we have to take care about smog, about dust, fine particles in the air of cities. So a very, very tight construction is a must for all of us. Sound insulation is a key in city centers. Security. Don't forget about a secure solution. A slider today is not so secure. Our TIGAL by TECHNAL has an option. I will show you later. Even in ventilation position, it has a base security. Last but not least, we want to have much as possible transparency, natural light inside, reducing artificial light, much as we can, ventilation inside. A little bit of design would not be too bad. I mean, I'm a German, but design is something I also like. So design is a key to accept and appreciate in the future. And last but not least, open it, have easy access, comfort in operating, and don't forget about the environment. The footprint 2020 you see on there, it is our aim as Hydro. We as TECHNAL, we belong to the Hydro group. It is our aim next year to become climate neutral, which means CO2 neutral with all our activities. This is the drive of Hydro, this is the drive of TECHNAL, this is in the genes of sustainability in TECHNAL. Next year, CO2 neutral. Then we made the next discussion. How should we design it? Should we have an opening device, a window? Should we have a top hung opening out, parallel, pivoted? A window to the inside. Building plot Hong Kong, 90,000 euros, 1 square meter. You want to open a window which is using 1 square meter? Okay, it's a nice investment to have a window, of course. But on the other side, also for the high-rise towers, I mean, it does not really make too much sense to stay with a window when you can have a solution like a slider. And for the ventilation, of course, also a slider has some advantages compared to the top-hung open-out solution. So the best compromise for the design brief was go for a kind of sliding solution with the performances of a window allowing maximum natural ventilation, but having the tightness of a window construction as well. So we went into this kind of design brief. Let's have the first glance, the first look on TIGAL by TECHNAL now. We have the scheme A already developed. It is one fixed area. It is one movable part. And the pretty interesting here is, normally you have a slider. A slider is a lift and slide, just a slide. Here it's projecting in parallel to the inside, and then you can slide. This allows you that you have no gaskets in the opening position at the frame any longer, so it's extremely easy to move the sash without too much force. And in addition, by having the construction like a window, it is as tight as a window. It is 4 times more tight than a slider construction. This was part of the design brief we have made, and I guess this example shows you the first glimpse of the product we want to show you later. In addition, when we see braving the elements even further, let's go into the technical details. I'm a German engineer, so I have always to come back to this one. Standards, we love standards in Germany. So we have a classification on water tightness E1200. I mean, it doesn't mean anything to most of us. What is 1200? It's 1200 Pascal. It means the wind pressure is 120 kilogram per square meter. This is pressure of more than F1 tornado. Furthermore, we have used 2 liters per square meter water and minute to test the water tightness. And as I said beforehand, it is 4 times more watertight than an ordinary slider construction. Pretty high performing, and it's even outperforming most of the window constructions these days. Higher wind tides, just remind yourself about the rain forces in combination with the wind loads. The next one is, of course, the wind. We have 2 options. The one is we can reach F2 tornadoes with a C3 classification, but we can even go higher. We can go up to 3,000 Pascal or 300 kilogram of weight on a square meter pressure, and here we also combined it with almost double as much water. Those who are not only in the European standards realize immediately 3.4 liters per minute and square meter is the ASTM standard. So our aim is, of course, to have an international appearance of this solution, being tight in all of our applications worldwide. Very important for all of us to have this kind of opportunities delivered. The next one is, of course, when we want to go to city centers, it is traffic, it is sound outside. The sound insulation with 45 dB is as good as an ordinary turn and tilt window. 45, and if you go for the traffic rated, it's still 40 dB. Which means when you live in a city center and you have a lot of traffic outside, you close the door, you close the window slider, you hear almost nothing from the outside. So easy to live and easy to sleep with a lot of comfort inside. The next challenge we have faced is how do we cope with the increase of temperature around the globe and the cooling demands. The construction we have chosen is coming from the non-insulated until the passive house solution. So you can even go straight to passive house requests with that kind of new window slider, TIGAL by TECHNAL, answering the overheating, heat increase, but also more weather extremes during winter period. And let's share together a pretty good video showing you a little bit the details of the slider construction to give us more insight about the technical engineering done by the colleagues in Toulouse, making that happen during the quest over the last 3 years with a lot of ups, not too much other things, but a lot of learnings on that one. That was wrong from my side. I come back once more. You see it's scheme A, so you have a fixed field, an opening field. Everything which is marked in red running around the sash are locking points. So we have 4-sided locking points around the slider, connected with the sliding rods, which are made here in green. And the really important is the bluish part. It's a patented bulkhead solution, which is really closing off the area where water is penetrating and where it should be tight. And this is a pretty interesting part of it. And please remind the shape of the hook. I will come back to this a little bit later. And you see the hooking device gives us the opportunity to have microventilation, but in addition also, of course, complete in parallel moving away from the structure. We can swallow up to 300 kJ, 2 meters times 2.7 meters. But now let's listen to the sound. And this sound is a simulated sound. Outside, you have 75 to 80 dB sound at the outside, and this is the real performance of the slider we have measured in our test chambers. So this is the experience you will have if you install the TIGAL by TECHNAL into your buildings, into your project plots. The next one is the acoustics. As said, 45 dB is a must, but even more important is big acoustics in combination with the possibility to reduce air conditioning, and this means ventilation purposes. When you have a slider today, you open the slider, you have a small gap. According to the gap, you get more and more air in, but unfortunately, you might also get people in you don't want to have. With this solution, we have a microventilation. When you put the handle at 90 degrees position, the complete frame is parallel going to the inside 5 to 6 millimeters. So we have a gap running around the sash, allowing ventilation. In this position, a room gets every 2 hours completely refreshed with new air. And this is also something remarkable and new, that in the secure position, you have ventilation possibilities. And this is something you should really consider to lower the climatic loads inside the building, and by this reducing the air conditioning needs and helping Paris to get cooler during summer periods, for instance. When it comes to the security, we have already done the RC2 testing. RC2 means a professional burglar tries for 5 minutes to enter. The professional burglars have not been successful because we have reached the RC2 classification. Then the next one is, of course, we have to consider about, you remind the first pages, I'm pretty sure. 1 person out of 5 in 2050 will be older than 60. 500 million, 500 million people will be older than 80. So easy access is a must for all the designs. And the TIGAL by TECHNAL, we just have a minimalistic threshold of 15 millimeters, allowing easy access without stumbling going there to the inside. To summarize a little bit, we try to do a little bit more than just good design. We want to be as sleek in the design as possible, as minimalistic on the frame as possible, as transparent as we could even reach. You have a choice between visible and concealed sash. You have the choice between visible and concealed drainage, but you have in addition a complete concealed fitting solution, which is also something giving more aesthetics to the architecture of the building from the outside and from the inside. To summarize in brief in a cross-section, the complete depth of TIGAL by TECHNAL is 151 millimeters. The infill thickness maximum is 53 millimeters, and the sash has 71 millimeters. In addition, we have thought about, of course, the concealed, completely invisible mechanism in between, but also we have the choice with and without connecting to the structure profiles. We call it BTC grooves, and this is something we are not only designing in TECHNAL a solution, we are also designing a proper installation phase. This is our aim, and of course you have opportunities for the hidden and the visible drainage, and we have a lot of space to the outside. Just imagine what you want to do there. You can put in balustrades, glass balconies, you can put in LED lights, for instance, for having a media facade during the nighttime, or you put in fly screens. So there's a lot of opportunities to be more creative in the coming projects than we have thought so far. As I said, you have the hidden and you have the visible sash. The hidden sash gives you the opportunity to increase the transparency up to 98%. So only the middle mullion will stay visible for the architecture, for the users at the inside. And in addition, this kind of concealed sash has one more technical advantage. It is hiding completely the outer area of the sash, and by this reducing the bay metal effect. So it's even easier to operate that slider during the summer periods. It's also a request coming out of the design brief. You have it in non-insulated and in insulated because it's a product for around the globe where you have different conditions, where you have different requests, but no hassle. If you have done it once, the other one is exactly the same. We are using the same articles, the same fabrication procedures, the same installation procedures. Everything is exactly the same. So you can have two options, thermally broken, non-thermally broken. And just remind yourself, you can go in the thermally broken down to passive house level. About the schemes at the moment already available, I said it like that. It is scheme A, one fixed field, one openable going to the inside, and this you can have on the right and the left-hand side. And we call it scheme K, which means you have a big fixed field in the middle and you have two openable sashes moving here, giving you a lot of opportunities to access balconies, terraces, and a lot of transparency when you have, for instance, your living room or your offices with a lot of natural light coming in there. To summarize, 300 kilogram infill. We have the opportunity to have 2 meter wide, 2 meter 70 high sash designs. It is the lowest operating force you can imagine. It's classified 1, so you have less than 10. It means less than 1 to 3 kilogram of power of force to move that sash. You should really make the test by yourself. It is easy to move. It is without any hassle. Anyone can open it and remind yourself when the slider construction and the beam metal of today, what kind of forces you might use today. And here it is just with a finger possible. This is TIGAL when it comes to the genes, when it comes to the design details, when it comes to how to answer the brief we have tried to forecast in the past 3 years. But then also a heritage from the Hydro organization showed us the way. You mentioned 2020, Hydro wants to become CO2 neutral. This we reach with a TIGAL solution with 2 options. Today, if you buy an aluminum window, 1 kilogram of aluminum causes 9 kilogram of CO2 emissions. If the production of aluminum is even used in coal-fired areas, it goes up to 20 kilogram of CO2 emissions. Okay? We have 2 new materials into TIGAL by TECHNAL. We use a 4.0, which is a primary aluminum, made almost 100% water-powered in Norway, reducing from 9 kilogram to 4 kilogram of CO2 emissions. And we have another one which is taking care of the circular economy of the urban mining, which is 2.0, which is a complete recycled metal. This metal has been already a window 40 years ago, and it's called infinite aluminium, and it has an average just 2 kilograms of CO2 emissions. What is 2 kilograms? What is 9 kilograms? What is 20? When you have a curtain wall, roughly around 10,000 square meters, you have approximately 100 tons of aluminum in there. So it's the choice of the planner. Coal-fired, it is 2,000 tons of CO2 emissions. 75, in this case, infinite aluminium, it is 200 tons of CO2 emissions. And do you know how long a tree must grow to swallow 1 ton of CO2? 80 years. Remind the 80 again, huh? Okay? 80 years, 1 tree needs to absorb 1 ton of CO2 emissions. Okay? So it's a lot to do. to become more aware of the society, to become more aware of the climate changes. Minimizing CO2 emission is a must for us in Hydro and especially for us in TECHNAL. And TIGAL by TECHNAL is the first solution. We really want to go into this CO2 reduced aluminium materiality, and you'll see a presentation later on just on that topic. It was a pleasure and honor to me to give you a little bit background information about the thinking of the engineers, about the design brief, and everything which tried to influence us to make a proper solution of a window slider which takes the comfort of a slider construction, combine it with the performances of a window solution for the best in city centers. So let's watch out. I have one more video on that one. And please remind, 80 could be a good figure of the future. Okay? Have a nice day. It was a pleasure.
Okay, so sorry, I think that we are just a bit late. You're really talkative, but it was really interesting.
It's not possible.
Really interesting.
Normally I'm always on time. You know?
So we probably have time for 4 or 5 questions coming from all around the world before closing this live session. So maybe a first question on the screen. Okay, we have Toulouse that is asking, do you plan to commercialize additional applications?
It's, I guess, a question for you.
Okay, I take it.
it.
I take it. Yes, obviously. Again, Werner already gave some inputs about that. Some of those were secret, but it's okay. The first application that we will launch in the near future is the two sashes central meeting style. So this is ongoing. We know how to do it. It's not easy, but it's ongoing. We plan as well to not stop on the RC2, but go up to RC3. And we also have plenty of other things, but we will let you know, because each time we develop something, it will be a new occasion to meet you with great pleasure. So, second question from Barcelona. How do you fit TIGAL among the rest of sliders offer? Difficult question. I will take it, sorry.
You must.
I take it. If you take, all the sliders have pros and cons. If you take the most advanced slider until now, which is the lift and slides in terms of performances, in fact, TIGAL with this new cinematics offers a lot of advantages. Ease of maneuver. You don't have gaskets that are interacting with the sliding. You have the micro-ventilation. You have plenty of advantages that make it easier and more comfortable to use, and also the sight lines for the architect are really thinner than the lift and slide.
I go for the next one, please. Okay? Otherwise,
Sure?
okay.
Yeah, sure?
Next one, please.
Okay. Next one for Werner.
Oh, no. Arvind, welcome, Dubai. I see Arvind in that kind of question. When will the TIGAL be available in the softwares, especially in Tech 3D for Revit 2019? Of course, we are doing it until end of Q2 this year. And even more, we put it into tech design and also into tech acoustics. So we really want to cover all the softwares provided by TECHNAL in addition to give the best possibility to support also the architects and planners with this kind of new solution. So Arvind, it will be soon in Tech 3D available.
Next question.
Next one. Lisboa, Portugal. How can I be sure of a correct installation?
I leave it to you.
Definitely. I'm the engineer, so
Yeah,
I try my best on that one. We in TECHNAL, we have two major areas of concentration. The first one is for sure to make the best performing solution. But it does not end as the best solution if you don't have a proper installation possible. So also on the TIGAL, you have seen we have these BTC grooves, these installation grooves, easing the installation procedure, enabling all of the guys who are doing production and installation to have the best possible installation of that window slider for coming now. So we really thought upfront on that one to make it happen, that we really get a better installed performance worldwide possible.
Good job.
Okay. The next one, may I? Singapore. Following which regulation have you done all the tests? Of course, as I mentioned slightly during my presentations, I'm a German engineer. I like standards, the DIN standards, the German standards, and also the European standards. And we have started, of course, on the European standards. We have done the complete test program on that one. But of course, I mean, when you have seen that we have done the first tests according, of course, ASTM standards, you imagine that we, of course, working for the next also on having international standards like the American standards inhaled into this new product launch.
Exactly. So I think that we will stop the live session now. Again, thank you all. Thank you, France. Thank you, Portugal. Thank you, Dubai. Thank you, Singapore. You have your own session now. So we will disconnect in 10 seconds. So goodbye. Have a great day. It's already a great day here in Barcelona and in all this country. Thank you very much.
Thank you all.
See you soon.
It has been a real pleasure. Thank you.